Yes, hi and welcome to this webinar on power quality. My name is Oliver Oberg and I'm marketing leader for the building segment in the Nordics, and I will introduce our speaking guests here today. So before doing that, I think it's good for us to have some knowledge on what to expect and how things are going. Do you hear me, Sten?
Yes, we can hear you, Oliver.
Perfect. I saw a comment in the chat, so maybe you need to put on the speaker. But yeah, you don't hear that if you don't hear me. So maybe can you assist me and write that in the chat? Thank you. Perfect. So while doing this, together we will take you through 45 minutes on good and solid information on the power quality and a few other things. Good for you to know is that this webinar is recorded, so we don't see you and we won't mention your full names or anything like that in the chat. So in that way, it's there's no problem. But you will in the all of the people who have participated in this will get an email in next week with both the presentation, as you will see it today, together with a few other good slides that may be handy and of interest for you guys, and also we will send you the recording of this if you want to share it with some of your colleagues or just want to watch it again to see, okay, what was it that they said about this and that. So yeah, really looking forward to this. So we have with us today, as you see in the screen, we have Janne Lindenius. He is a business developer located in Finland. At Schneider Electric, both of them. So, and then Sten Jørgensen, power quality specialist located in Denmark. But of course, they together cover all of the Nordic countries. So, with that said, yeah, I'll leave the stage to you, Sten. Or Janne, sorry.
Thank you, Oliver. So, good day, everyone. I'm happy to see so many people in this Schneider webinar of EcoConsult Audit for Power Quality. My name is Janne Lindenius, and today we present you the Power Quality Audit Service. We will explain you in this webinar what are the issues of imperfect power condition, how do we find them, and most importantly, why do you need to take care of the imperfect power condition. Let's get started. Next slide, Oliver, please. Yep. So, on the agenda today, we will speak about the importance of the power quality. Why to care about the power quality? What kind of challenges there is in the modern electrical networks, power quality network trends, a little bit of the network and asset management, some key financial and technical factors. Then I will also present how Schneider Electric can support you, and last the EcoConsult audit in brief. Can you go one slide back, Oliver? Thank you. So we start the webinar with the importance of the power quality, why this matters. First, the compliance to the utility guidelines. We have seen increasement of the power utility guidelines on power quality. It starts to be quite normal today in Nordics to have 3 variables in your electricity bill affecting the bottom line. The variables are consumed energy, peak power demand, and reactive power charge. Each of the variables is directly affecting your bottom numbers. Variations on these charges are based in the region on how utilities utilize these charges. Energy efficiency has a direct impact on the energy prices. Market has seen a staggering 47% price increasement on year in renewable PPAs during the last years. More energy we are able to save, there is a more energy capacity to offer to the market. When demand and supply are in balance, the price stays level. Every kilowatt hour counts here. Additional bonus from energy efficiency is the lower cost of build. High efficiency devices will bring you same output with lower energy demand, leading to a lower capex cost. Then we need to notice also the changing customer load types. The change of the load type has been dramatic when you think of the effect to the power quality. We see more and more computers, high power of them, UPS systems, advanced automation systems full of servers and so on. Each of them creating non-linear loads to the network affecting the quality of the power. Yet today, the impact of the power quality improvement is still one of the fastest and easiest way to improve the profitability of your goods sold. Return of investment times are normally measured in months instead of years, with a minimal capex investment. You can see in the right side of the slide some important questions you should ask or think about when you're thinking of the power quality, such as which are the electricity bill and do I have the right information at the right place, metrics about my power quality and risk I may face. Next slide, please. Okay, why to care about the power quality? According to our study, 3 to 6% of the manufacturing sales euros are spent on correcting power quality problems. Up to 50% of the power outages are originated from power quality issues. Some 70 to 80% of the disturbances are born inside the facility. 8 power quality events per year is a typical power quality event number. As you can see, the power quality issues are quite common throughout the industries and PQ have great impact on bottom line figures. The benefit of improving of power quality are quite numerous, as you can see. The main benefits are reduced OPEX and CAPEX costs and increased equipment and power reliability. Next slide, please. So what are the challenges of the modern electrical networks? In this slide, there is a collection of various imperfect power challenges, and we will come back to each of these later on this webinar. What we have seen is that the sags and swells are the challenge number 1. Challenge number 2 is a bit more complex, and what we can see is that the power factor, harmonics, and phase unbalance are more and more less equally usual. Third one is the energy challenge. More of these ones will follow on the next slides. Next slide, please. Sags and swell, the challenge number 1 example. Schneider Electric survey in North America gave us some insight of the power quality issues we all face today. Over 50% of the power quality issues comes from voltage disturbances. Typically, customers face 5 sags per month and 1 interruption per every 6 months. Next slide, please. Power factor and harmonics, the challenge number 2 example. We all have been seeing victory of the LED lighting. It has a direct energy saving outcome, no doubt about that one. But it also brings with them a power factor and harmonic impact. LEDs are excellent source for trouble regarding these 2 power quality issues. Next slide, please. This is a network and asset management example of the harmonics. What harmonics does is that it heats up the equipment, leading to a premature failure and costing you increased OPEX money. Harmonics also increase currents in the circuits, leading to trips in the breakers and causing you unnecessary process stops. Harmonics are also source of noise for sensitive equipment, which may react to noise, giving you false information or production shutdowns. What you see here is 2 examples of the cause and effect. We will come back to these examples later on in this webinar. Then we also need to notice the energy losses. Energy losses are directly proportional to the squared current of the transformer in the transformer coils. Increased current increases the power cost, leads to oversizing of the equipment, it reduces the lifetime expectancy of the devices, and it causes nuisance trips. Next slide, please. So where do we need power factor correction? Challenge number 3 example. The most common is when your utility charges for reactive power charges. The amount of the reactive power taken or given and the charge depends on the utility. As you can see from the charts, the power factor varies between facility types and device types. Facility range starts from 0.7 and device range starts from 0.4. The target for power factor in most utilities is above 0.9 level. Next slide, please. What we have here is a screenshot from a study done for utility provider in 2011 located in the second biggest city in Finland. The simulation of the effect of the power factor is made for a customer of utility using 2 gigawatt-hours of electricity per year. Simulation data points are taken from real-life recordings averaged on 2009 and 2010 from the utility data. We can see from the chart in the left side is that for reactive power compensation charges can be 5 times more expensive depending on the utility area you are located. More interestingly is the fact that if the customer would improve the power factor to 0.9 level, the highest charge would drop from 32,000 euro level to 6,500 euro level. That is resulting whopping 26,000 euro savings per year. Next slide, please. There is some key financial and technical discrimination factors to be considered here. Effect of the low power factor on main transformer power margin. That will lead to a risk of equipment oversizing. Power transformer safety margin increased thanks to the reactive energy compensation. Less kVA will go through the transformer, allowing a smaller equipment sizing. Overloads and overheating risk reduction. Reduced current will lead to improved voltage level, reducing the overloading and heating conditions. The total paid and unused power losses causing reduced service life of the equipment. Iron losses reduction in the power transformers and cables. Less current means less losses. Up to additional 10% with the harmonic filtering. A reduction of the harmonic portion from the system reduces the harmonic effect. Energy bill total savings per year. Risk on higher subscription costs. That's a direct financial benefit when paying the right energy used. Return of the investments are lower than 18 months with the power factor compensation systems. Next slide, please. To continue, under-voltage operation to the reactive power is directly impacting the process levels, risk of machine and process performances. Busbar voltage close to nominal value ensures a better operation of the machines, and that's a direct benefit on process quality. CO2 footprint reduction based on the kVAR reduction. Estimated footprint impact is X kilograms per CO2 per year every kVAR, and direct benefit on the CO2 footprint and environmental impact. That's a compliance with the sustainability objectives. To summarize the benefits, reducing the energy usage will lead to fast return of the investments, save on electricity bill, reduce investment by optimizing the equipment sizing, improve process reliability, improve equipment life and lowering the life cycle OPEX costs. Next slide, please. Now, if we look at the power quality from a holistic point of view, it requires more than the assessment of the issues. It's a process, which can be performed by assessing the power quality, reducing the energy waste, collecting the relevant data, visualizing the key metrics, and maintaining the status with the services. Power quality audit is here to help establish full end-to-end sustainable and resilient CO2 limitation process. The service starts from assessment of the power quality to locate the problems. Once the source of the trouble is clear and proper design to mitigate is done, we move to reduce energy waste. With the help of Schneider Electric market-leading solutions such as AccuSign filters. Part of the process is to collect the relevant data with the leading power metering solutions. And final step is to visualize the metric systems with such as Power Monitoring Expert or Energy Hub. Then once all is fixed, you want to maintain the level reached. The best way to do that is with the service agreements from Schneider Electric, ensuring your operational capability levels for years to come. Next slide, please. The power quality audit from Schneider has 2 service levels to cater to your different needs. They both have a single objective: make a site assessment of the global power quality level and provide recommendations in order to reduce the impact of power quality issues coming from the grid or generated inside the plant. The essential service is based on a site visual inspection and data collection. In case all required data can be provided by the end customer as per our interview guide and questionnaire, submitted or used, the site visit could be skipped. Advanced service is based on site visual inspection and measured data collection. The first data collection step are included in this approach, and the data collection will be completed on site during the site walkthrough. A temporary power quality meter will be connected to all strategic feeders where the information should be measured or improved. The customer facility manager will need to grant the access to these measurement points. Next slide, please. Okay. In short, the difference between the service levels is that in essential service, we utilize the existing data, and in the advanced service, we measure the data. The essential service becomes awfully handy if you can measure yourself, but you need an analytics expert opinion on the source of the power quality issue. On the other hand, advanced service will give you everything what you need right away, without any interruptions or in between with the third party in the process. With that, we move to the expert interview part of this webinar. With me today here is Sten Jørgensen. Hi, Sten. Sten, you are muted. Still can't hear you. No. Try now, Sten. Okay, folks, I think we have a little bit technical issues with the voice now. So we can't hear you, Sten, if you try to speak at the moment.
Sten, try next to mute, you have a little arrow, and then on the microphone setting, you put that to your headset. Yeah, so while Sten is trying to get on board here, please feel free to write questions in the chat. And when doing so, we will answer all of these questions in the follow-up email afterwards. So yeah, the questions on why the microphone doesn't work, yeah, that I can't answer you. Maybe we can come back with that one. But yeah, so feel free to ask any questions if that's possible, or if you feel like it. Perfect.
So let's hope that we will get Sten also on board really soon.
Yeah, we tried this, of course, on forehand, and then everything worked. But yeah, the techniques can do some incredible things sometimes. So let's hope.
Precisely. Yeah. So we have some fantastic customer stories to come and explain about the power quality solutions and different kind of projects what we have done together with the customers, and they are really interesting to see and hear. So let's hope that we get the voice also audio up and running with Sten.
Yeah, we got a question in the chat. If you have any good stories on customers that have helped that could serve as inspiration, and we do that, right, Janne?
Yes, we do. We have 4 different cases, if I right remember, in this webinar up and coming, what we will present you. And then also in the material, what we are going to share is links to those customer informations if you want to discuss and about Schneider solutions directly with our end customers. That is also possible.
Yeah, very good, very good. Yeah, so you have that to look forward to, either via Sten right now.
Can you hear me now?
Oh yes,
oh, yes.
Beautiful.
There you are.
The stage to you, Sten.
Sorry. Come on, Janne. What did you ask?
No. Welcome, Sten, to the webinar as well.
Thank you.
Okay. All right, now we are over with the technical difficulties. So like I said, with me today is Sten Jørgensen. So Sten has the decades of experience of the power quality issues and resolutions for them. So welcome, Sten, on board, and we will kick off this expert interview part with the questions for you. So let's begin with the discussions of the imperfect power. What can you tell us about the imperfect power? What is that?
if you look at imperfect power, there's actually some guidelines for that. We have the EN 5160, it's a European norm, and we also have the EEE 590. It talks about harmonics in general, and power quality and so. But imperfect power has also a lot to do with the utility company actually providing the power for the factory or whatever the user is. So often there is some compliance we need, some rules we need to comply with for the general electric distributor force.
Fantastic, good to hear. So what kind of effects there is for imperfect power conditions to the customer?
Yeah, imperfect power can do a lot of damage for sure, because we can actually overheat our transformer or our UPS system or generators, and we can get the control system to do something wrong in the facility, or we can have motor failure, and yeah, have a lot of a nuisance in the factory. And for sure, one of the biggest nuisance is actually if we have some shutdowns, if we have a blackout. And I've noticed there's some of the participants that actually have a data center. You can imagine what happens if a data center is having a blackout. That would not be nice. And for sure, I have customers also that need the production to run perfectly all the time. So that's an issue always if you don't have good power factor, like good power quality.
Super. Then there is a talks about these transients. Where do the voltage transients come from? What's causing them?
A lot of time is actually from the installation itself. It can be big motors, big heat pumps with big motors starting up in the system at the customer side. It can be, a lot of things actually inside your own system. But there's also a lot of transients coming outside the facilities, because we know there's a lot of windmills, solar parks and everything. And every time these are coupling on the main grid, it can create a transit into the system, and the transit will actually go through the distribution transformer into your system. So you can have a lot of issues with that. And you have to remember, big transits actually destroys a lot of components.
Good information. So let's talk a minute about the power factor. Why it is so important to any business?
Power factor is actually a good thing to have quite high, because two things. If you have a power factor at 0.8, you have 20% loss in your installation. That means that you actually lose capacity in the installation. You will actually heat up your installation because the power factor is actually just converted to heat in the installation. And then a lot of times also you have the utility company saying that you need to be over 0.9, because they don't want to have the loss in their installation. So it makes good sense. And then again, if you can have, let's say, a power factor at 1, it would actually be quite nice, because then the CO2 emission in total will actually be quite small. So every time they talk about we need to set up more windmills, we need to add more solar farms because we need to have free energy, it could be nice to look at the power factor. If we have high power factor, that means we're using all the energy we put into the system. Then it would be a good idea, actually.
That's important information. So about the penalties on different utilities. So how do I know, am I paying any of these charges?
And normally it would actually say in the invoice you're getting from the utility company that you are paying for reactive power. And it was, as I've seen it in Norway, I've seen it in Denmark, it will actually be a line like you are paying for this amount of kilowatt hours and you are paying this amount for reactive power. You'll see it directly on your line. So often it's like that.
Okay, good to know. Let's change the topic for a moment into the power quality mitigation and the harmonics. What are the harmonics in the network and what are the sources for those harmonics?
Harmonics is made by almost every electronic part we connect to the network. That means LED lights, it means TV systems, it means computers, servers, frequency drives. That's the most important part because they pollute a lot. But every electronic part is actually sending some and making some noise at different levels. The 50 harmonic, or first harmonic, is our 50 hertz system. It's a nice, easy, clean wave. But if you have a lot of LED lights, it will actually make a draw a current on the third harmonic, and that's 150 hertz. And you need actually to put this current at the third harmonic on top of the RMS current. That means that you'll get a spike. And this is also, it's not an active current. We have to remember that means that we don't pay any money for this extra consumption, but it will actually heat up the transformer, like power quality, power factor. So it will heat up the transformer, heat up the motors, do a lot of nuisance in the system. And if you have 3-phase drives, it will be 5th and 7th harmonics. So it can actually be quite big, this extra current running in the system.
Yeah, interesting. So you mentioned a little bit about the effects of the harmonics. So why are the harmonics so bad, and what can they cause to my business?
Let's, as an example, you showed a motor that was quite hot in the introduction, and it can actually happen that when you have a lot of frequency drives in the system, it can be on heat pumps, cooling system, whatever. You have 3-phase motors. Then you have some standard motors just running. When you are running with a frequency drive, it will send 5th harmonic into the system. When you have 5th harmonic in the system, it's actually what we're saying is running at negative. So it will actually rotate clockwise. But if you have the 50 hertz only at the motor, it will be anti-clockwise. So if you can see, it will turn against each other. So it actually means, if you take a picture, that you're running on a bicycle, but you're always trying to use the handbrake. So you will not get the efficient out of how you're pedaling. So it would be so nice if you removed all the 5th harmonic. That means you let go of the handbrake and you just use all the power connected to the system. So often you see standard motor burning because there is 5th harmonic in the system. It can actually, the bearings can actually, because there's a lot of vibration, so they can actually also burn
Yeah, super interesting information. Oh, let's talk a minute about the actual power quality audit. You have been doing these ones for quite a long time. Can you tell us what happens in these audits, and what about the report of the audit? Does it also contain the proposal for the solution to fix the issues what we are looking after?
Exactly. And I think actually, Oliver, could you try to jump to the next page, because we have some pictures. Yeah. In these pictures, you actually see some standard panel meters. It's high-end meters for sure. That means that they can measure approximately everything. In this case, we have a 9000 suitcase. We have them, and we have PM8000 also in a suitcase. And these systems are actually connected to a hosted PME. That means there's a SIM card inside, Tosi box with SIM card, so it sends everything to our hosted server. That means that we can sit and look at what actually is happening into the system. Next page, please. We also have third-party meters. That means that we can go out and measure with a third party and make reports on these. So it's quite nice to have a lot of different things to connect. But we also have to be quite aware of that Schneider is not allowed to work on a system with power on. So we need to disconnect, or the customer needs to connect itself with Schneider as a consultant standing beside him. But we are not allowed to do this. But as you can see in the small picture here, we can actually set CTs around the cables. So if that's a possibility, then there's no problem for Schneider to connect. Next slide, please. And one more time. And if we are going to measure, for sure we are going to measure a lot. And here's quite a small example on a report. But what we are doing, you get all the measurements on everything measured on the system. But we will highlight if we see anything and come up with some comments and for sure a solution how to fix. And that will often be the case here.
Great, that is interesting. What do you need to consider when we do the installations of the fix of the power quality issue?
Yeah, we have to be very aware of how the CTs are connected, because we need 3 CTs connected to the system. And if these CTs are located in a wrong place, we can actually pollute the system with more. That means that, let's say the CTs are measuring a level of 30% harmonic current, and you have a set point that says 5, it will actually try to put in harmonic current, but 180 degrees opposite, so it's working like a noise cancelling system. But if the CTs are put in the wrong place, you can actually pollute the system even more than you're actually measuring. So it's very important to have the CTs connected correctly, and if they're connected correctly, you only need 1 breaker. So it's quite easy to install this.
That sounds easy one. Coming back to the justification for the investments then. So what does imperfect power look like to the customer business?
I would say the biggest, you're not saving any kilowatt hours by installing an active filter, or that's it, or even a standard PFC, a power factor correction system. But you will not overload your system. You will not have any, possibly not have any downtime. I cannot say anything about the mechanical side, but electric side is quite good. And we have customers that actually buy filters just to be sure they don't have poor power quality, because they don't want any stops. So that's very important for the customers. No production stop.
I can imagine that. We have stated that power quality will improve the sustainability and the compliance. How?
Yeah, when you're talking about the sustainability, is for sure that when you have a harmonic current running, you will also have a harmonic voltage, and the harmonic voltage will actually ruin components set up in the system. That means that you will overload the different. It could be a transformer, it could be actually drives or LED lamps or something like that. It could actually be, yeah, the lifetime of that will actually be quite low if we have harmonics in the system. So it would be a good idea to look at the power quality for sure.
I can imagine. Fantastic information. Hey, then you promised that we can see some customer cases of the power quality audits and the end results. I think we have a slide on that one. So Oliver, if you can change the slide. Yeah, exactly. Can you walk us through with these cases then?
Quite fast. Yes, we have made some installation at Scanline. Scanline, the class society actually said that Scanline was not allowed to use the ships. So you can tell me that that's also something called downtime in that case. But they needed to fix the harmonic issues on these boats because they were quite high. We did that actually by installing some 200 amp filters, 2 on each ship. And they were allowed to sail again. And I know in the end, I have some contact persons also, so you can see if you need to talk or write an email to these contact person from Scanlines, they will actually be happy to answer your questions. Then we have Smurfit Kappa. Smurfit Kappa actually had, let's say it was back in 2015, I actually offered filters the first time. But now in 2023, they actually had some breakdowns that cost them quite a lot of money. So now they have installed filters, and they actually set us up so we can measure on filters in Sweden, not on measured on factories in Sweden. So they need actually to install more filters in their installation. Then we have 2 aquaculture, sorry, fish farms, one in Norway and one in Iceland. They are also using filters because they have a lot of inverters. So they are polluting their own system and they don't want any pumps to stop. If they stop, they can lose millions. The biggest one, First Water, is coming up to producing 55,000 ton per year of salmon. So it's quite a lot of money they have in these big pools they have. So yeah, but you will have the contact persons if you need to ask them any questions.
That's great. Okay, good. So thank you, Sten, for a very insightful information of the power quality issues and Schneider Electric solutions to them.
Yeah, and sorry about the sound.
No worries about that one. This is the normal thing what may happen. Oliver, can you change the slide, please? Okay, good. So we will close this webinar with the final words of the EcoConsulting portfolio. The power quality audit is a part of bigger consulting offer portfolio from Schneider Electric. The portfolio consists of following services. We have electrical digital twin, meant to increase digital simulation environment of your physical electrical distribution network for simulation and design purposes. We have audit for power. It's a life cycle service for installed base information. So if you are looking for information of the maintenance requirements, modernization possibilities, monitoring solutions, or management information, this is the service to catering those needs. Audit for power monitoring is designed to serve the need of monitoring system designs. As a new regulations from EU and local governments progress to sustainability and energy efficiency targets, the need for a modern monitoring system increases. The service idea is to enable customers to invest into a monitoring system that makes sense. There is no need to invest expensive monitoring systems for places which does not require power consumption monitoring. Audit for industrial automation is basically the same service as the audit for power, but it also has some quite neat features for the PLC replacements. Schneider has developed a great tool that enables customers to perform partial retrofits also for the third-party solutions and products. Automated software conversion tools is naturally part of the automated tools. If you are in need to make modernization on PLCs, please get in touch with us. In system studies and design service, we can help you out to design your electrical distribution network. We utilize our market-leading tool, ETAP, on this service. We do perform the standard electrical design engineering studies as per your needs. We have a great experience from various markets such as data centers, retail, and food manufacturing industries. Latest service added to this portfolio is the energy efficiency audit. This service was created to offer customer a holistic view on energy streams within their facilities. This is an excellent service if you need to have information of where to start with your energy and CO2 reduction programs. Outcome of this service is scenarios with calculated values for energy savings, CO2 reductions, and investment costs. That's an excellent service if you need options in the table to make requirement investment decisions. If you have any need for any of these services, please feel free to contact Schneider Electric local contacts. With that, I close my part of the webinar. Have a nice weekend, and back to you, Oliver.
Yes, thank you very much, Janne, and thank you, Sten, for joining us today. I think it was a very interesting webinar. So hopefully our attendees can do feel the same, and please feel free, as I mentioned before, feel free to drop a question in the chat. You have it down in the right. If you have any questions at all, then we will come back to you. And of course, also as Janne said, if you have any further questions at this at all, just feel free to contact us. You have all of the contact information and so on the website, or if you have a designated salesperson or a sales rep or a technician today, just speak with them, and they will lead you the right way to gain access to this kind of content. Also, as we just said, this whole webinar, everything that you have heard today, the recording, you will see that in the email that is up and coming, and also you will get your questions answered there. So I will leave the webinar up and running for a while. So if you have any questions, you have a lot of time to put those in. And with that said, Janne, again, thank you so much for enlightening us today. The same for you, Sten, and also Sofia Karlsson, as you have not seen her yet, but she is in this call as well. She has coordinated it in the best way, shape, and form, and big thanks to her. So with that said, thank you all for joining. Have a nice day, and when it comes, hopefully a nice weekend. And yeah, we'll see you in the next webinar, or we'll hear from you. Okay.
Thank you.
Yeah. Bye, guys.